Hey folks, this is section 9.1. I'd like to take a look at some of the identities that you're going to be working with in this particular chapter. Some of these identities we've already worked with, such as these quotient identities. You've seen every single one of these in some form or another already this semester. We know that cosecant of an angle, or cosecant of theta, is the same thing as 1 divided by the sine of theta. We know that secant of theta is the same as 1 divided by the cosine of theta. Honestly, folks, this is something that you should know very well by this point in our semester. Tangent, we've actually talked about tangent in several different ways. So think about SOHCAHTOA. We said that tangent of an angle is opposite over adjacent. Or we would say that tangent is my y value over my x value. Think about on the unit circle what the y value is. That's the sine value. So we would say that this is the sine of theta divided by the x value, and the x value is the cosine of theta. So tangent quotient identity then is the sine of theta divided by the cosine of theta. The cotangent of theta we know is going to be 1 divided by tangent. But then we also know, because of what tangent was, if tangent and cotangent are reciprocals of each other, and if tangent is equal to sine over cosine, then we know that cotangent is going to be the reciprocal of that cosine over sine. Next, we have something called the Pythagorean identities. Before I talk about the Pythagorean identities, I'd like to talk about the square, because you'll notice down here at the bottom of the page, you've got a whole bunch of squares somewhere around your sines and your cosines, etc. What exactly does that mean? So what I have right here is an example, sine squared of theta. This is the same thing as the sine of theta times the sine of theta. Technically speaking, we could have written this as the sine of theta whole entire quantity squared. However, what I don't want you to start thinking is that it's the same thing as what I've written over on the right. This is not the same thing as the sine of theta squared. Sine of theta squared simply means that theta alone is being squared, where I have a sine of a theta times a theta. That is not what we were looking at the beginning. So when in the Pythagorean identities, you see something like this right here where it says sine squared of theta, understand that this is the entire trig function times itself. With that in mind, let's talk about these Pythagorean identities. And remember that the word identity is basically a fancy word for rule. So these are the Pythagorean rules. They're always going to be true. My first rule is that sine squared theta plus cosine squared theta is equal to 1. And you see that underneath this, I have a couple of other ways to write the exact same thing. Think with me what you would do if you wanted to get cosine squared by itself. You guys all know that in order to get cosine squared by itself, you would take the sine squared of theta and you would subtract it on both sides. So with that said, cosine squared is the same thing as 1 minus the sine squared. These two lines are exactly the same thing. They're just simply rearranged versions of each other. Same concept, if I wanted to get sine squared alone, then I would just subtract cosine squared from both sides. So that would be 1 minus cosine squared. So this is the first Pythagorean identity, and yes, it can be manipulated, it can be rearranged to look different ways. The second Pythagorean identity is the one that says 1 plus tangent squared of theta is equal to secant squared of theta. So once again, if you wanted to get tangent squared alone, you would subtract 1 on both sides. So you would have secant squared of theta minus 1. And then lastly, if you went back up to the original question and you wanted to get that 1 alone, then you would just subtract tangent squared from both sides. So you'd have secant squared theta minus tangent squared theta. Again, these are all the same Pythagorean identity, just rearranged versions of the same thing. The last one that we have is 1 plus cotangent squared theta is equal to cosecant squared theta. If you wanted to get cotangent squared theta alone, you would subtract 1 on both sides. So you would have cosecant squared theta minus 1. Or if you wanted to get the 1 alone, you would subtract cotangent squared from both sides. So this would be cosecant squared theta minus cotangent squared theta. And those three then are the Pythagorean identities, along with some rearrangements of those exact same three identities.